And here we are with cyclohexane. Cyclohexane is awesome. It's the part 3.7 in your book. And cyclohexane is the best ring you could possibly have. Okay? Beyonce would be happy to have this ring. Because if you look at this particular molecule, if you look at the way this ball and stick diagram is shown, you can see that these are in antipositions, and this is a staggered interaction between those green balls. Look over here. This is not in the same location as that. So again, that's going to be a staggered interaction. Remember, staggered and eclipse. This is staggered, which is more stable. All right? These two are staggered positions as well. Again, two staggered, staggered. The only eclipsing interactions that I have, if you are using your mind and looking at the molecule that way, looking for an eclipsing interaction, is if you look up on top. Do you see that? Those three red balls that are there, those three red balls represent hydrogens which are held up in an axial position because they're axial. They're perpendicular to the plane of the cyclohexane. And in doing so, these hydrogens, while they're anti to these two, these ones are in eclipsing formation. Okay, so any axial interactions that I have in a cyclohexane, those are the ones of high energy because those are the ones that are going to be strain-inducing because you've got eclipsing interactions. Remember, eclipsing is bad. So this is the one carbon. 1, 2, 3, 4, 5. 1, 3, 5. We call these 1, 3 diaxial interactions. Not 1, 3, 5 because this is a 1, 2, 3. Okay, 3 carbons away. 1, 2, 3. All of these things are 1, 3 away. Okay, so we call them 1, 3 diaxial interactions. All right? If you look at the space-filling model of this thing, you can kind of see that it's sort of a Christmas-colored blob there. All right? I'm not going to try to show you what this looks like. It's better represented using the ball and stick diagram, but the space-filling model, you can kind of see that this one's up and this one's down. And when that happens, there's kind of a push that goes on, and that push is going to stabilize the molecule. So cyclohexane, as opposed to cyclopentane, which is also quite stable, cyclopentane has got 2 eclipsing interactions. Okay, cyclohexane has 0 in this form. Now, if you look at this form, remember that chaise lounge I showed you in the previous chapter? This is kind of the head, and this is the tail of the chaise lounge. You can kind of see that it's kind of a chair. If you're insane, you can see a chair there. Okay, but this is what we call the chair formation. Okay, if you look up top, this is what the Newman projection of the molecule looks like. You can see that everything in this molecule adopts a staggered conformation. And what that means is that this thing is as close as you can get to adopting the 109.5 bond angle that you're going to need to be as stable as possible in a ring structure. Okay? Once you get down to 109.5, there's not a lot of strain, so these electrons aren't repulsing themselves quite as much. Okay? So we've moved down, and these are the cyclohexane positions. All right? It's a 1, 2, 3, 4, 5. And what this is showing you is what the cyclohexane looks like if I just draw it out by sticks. Now look at this. Notice that this and this, the 2 blue parts, are parallel. The 2 red parts here, those are also parallel. And these 2 green bits, they're also parallel. All right? Everything on a cyclohexane, there's got to be some sort of parallel correlation. That's here. Okay? And if we show it using sort of a 3-dimensional representation, this black area is coming at you. Okay? So that's a 3-dimensional image. This is coming closer to you, and these are going away from you. So that's what you end up seeing if you look at this from the side angle. All right? There's also a different chair conformation here. And if you look at that, you can see that, and you say, whoa, what is that thing? This is what we call a skew boat, all right? Or this is a boat conformation right here. Not the skew boat, excuse me, but this is just the boat conformation. You can kind of see the boat. You know, you've got the bow and the stern right here and the 2 sails coming up and the 4 paddles in the ocean, and this is the dragon head and this is the dragon tail, and a couple of Vikings are up on here, right? And you can kind of see a boat in that formation, okay? So this is the boat. It's not as stable as the chair conformation, but it is still pretty stable. The difference in this is that if you look at these 2 blue balls, or the 4 blue balls that are down here, they're obviously eclipsing. And once you have that eclipsing interaction, it's going to be a higher in energy structure. Okay, so this is higher in energy. Here's a space-filling model of it. Okay? And right there, that B structure that's right in front of you, this thing is called the twist mode. All right? We start skewing it. And in trying to skew it, what we do is we make it sort of a more stable boat than what I showed you up here. And in doing so, what this does, instead of being eclipsing right on top of each other, these two things kind of skew out just a little bit, and that decreases the amount of energy there. Represents a skew boat operation. Okay? So that's the basics of cyclohexane. But I'm going to pause this, then the lights will come back on, and I'm going to show you, because you're going to have to know how to do this, how to draw a cyclohexane. Okay, now I'm back, and I'm going to show you how to draw a cyclohexane. Remember what we had showed you before, that everything was a parallel line, okay? The same thing applies to how you draw these things. Now, let me show you how I draw them, because I've drawn them for several years, okay? Well, not like that. See, you get cocky, and that's what happens. Let's try this again, all right? All right, cyclohexane, okay? I can draw it that way. By the end of the semester, hopefully you guys are drawing it this way too. But it gets a little bit of time to get used to how these things are, all right? I can also draw them this way, okay? Another cyclohexane. You can draw it that way too. You can practice this. But if you're having some trouble, draw it by parallel lines, okay? First thing I do is I draw the first parallel line, and I'll draw the second parallel line over here, okay? They're on opposite sides. Next, I'll draw that line, and then I'll draw that line, okay? Parallel lines established, and then another parallel line, another parallel line. And voila, you have yourself a cyclohexane. Now, I'm going to use this blue color because I want to show you this. I didn't show you this in the chapter, but it's going to be important for when you're drawing cyclohexanes, okay? So I got the cyclohexane here. If you notice, these are two parts of a carbon. Remember, we've got a tetrahedron that has to be here. So I've got one side and one side over here. So let me show you a tetrahedron. Okay, so there's one. Here's a wedge, and here's a dashed part of the tetrahedron. Okay, and I've got one line coming up, one line coming down. Now I've got these two parts of the tetrahedron. 1, 2, right here. Okay, which means I've got two other parts of the tetrahedron that have to be supplied for this particular drawing. So I've got two other bonds that are listed there. Now, those two hydrogens that are there, what are they parallel to? Okay, this one is parallel to this line and that line. Okay, what's this parallel to? Do you remember what I said about the axial positions? They're perpendicular to the plane, so they're not parallel to anything. The only thing that these are going to be parallel to are other axial positions. Okay? All right. Notice that every apex that's here has a hydrogen that's shooting up out of it. Okay? So that when you're drawing these things, you want the hydrogens on the apexes that are pointing up that way. If I've got one that's pointing down, okay, this is how I want to represent the hydrogens, all of them pointing down. Now, if I've got a different position, say down here, okay, here's my wedge and here's my dash, notice what happens. Here's the wedge, here's the dash for this thing, and I've got two positions. So this other hydrogen has to be sticking out from the side. And notice what that's parallel to. This one is parallel to which line? That's right, this one up here and that one over there. Okay? Poor placement of the one right there. So let me draw this and draw one. Now notice what I've done. The hydrogen that was in back, I've drawn a broken line. Okay? I've done that to represent that it's in back. If I did this and drew a line continuously over that, okay, what is that? Is that in the front or is that in the back? I can't tell. What you have here is the beginnings of an MC Escher diagram. Don't know who MC Escher is? Look it up, kids. It's arc. Okay. MC Escher did a bunch of those crazy surrealistic type of paintings. Okay. Do you remember the one with all the staircases going up in different positions and people walking up and down, that kind of thing? Tell you what, I'll show it to you here in a minute. Okay. But this is how we draw the hydrogens that are on a cyclohexane. If I draw it the other way, if I want to do the other chair conformation, because there's two, there's a chair flip form. Okay, again, two parallel lines, parallel line, parallel line, parallel line, parallel line. And again, you've got another chair form cyclohexane. All right. So that's chapter 0.6, 3.6. That's what chapter we're in. So that's 3.6, and we'll move on to 3.7 here in a second. All right. Now here is the M.C. Escher image that I promised you. You can sort of see what's going on here in this particular image. You've got people who they're all walking up the stairs. They're walking up the stairs and coming down in the way that this is kind of superimposed, that nothing really seems to make sense in this particular image. Okay, this is one of his earlier works. There's some other M.C. Eschers. This is kind of a duplicate of one that he had. You guys probably have seen some of the other ones. This one is also kind of an M.C. Escher type image. It's built off of his swans, the black and white swans. Have you ever seen that? Let's see. This one I think is more famous. Okay, people walking up the stairs and sitting at different angles. Everything here seems to defy gravity. You can see that this guy's sitting on the wall type thing. Well, you got an M.C. Escher diagram. It makes no sense, and it has no real perspective. So I don't want to catch you guys doing the M.C. Escher type thing with your chair form cyclohexanes.